Hello Primary 5, Ms. Hiba Ahmed with you. Today we will continue our lesson magnetism and electricity, and we will take part 2 from this lesson. You remember the electromagnet and the structure of the electromagnet, and don't forget that in the electromagnet the electric energy is changed into magnetic energy. Today we will take the other example of the generating of the electricity by using the magnet. So today we will talking about generating the electric current, as you can see here, by using a magnet. The English scientist, which is called Faraday. Okay, Faraday was an English scientist who discovered the dynamo. This is the dynamo, as you can see in this picture. Okay, what is the dynamo? The dynamo is consists of copper wire and a pair of magnets and a lamp. Okay. When we move the magnet, inside the coil of the copper wire, there is an electric current generated. What happened here? Faraday moved a magnet, a power magnet, inside a coil of copper wire and connected the end of the two ends of the copper wire with a lamp. When he moved the magnet inside the coil, turned the lamp light. When he stopped moving the magnet inside the coil curtains of the copper wire, the lamp stop lightning. Okay, so the magnet here, generates an electric current, not the magnet. The motion of the magnet. The motion of the magnet generates an electric current. Why we can't see the magnet generate an electric current? Because when the magnet here is not moving, there is no electric current that is generated. But when we move the magnet, inside the coil of copper wire, the electric current generated. So here we cannot say the magnetic energy change into electric energy. No, because magnet without movement, there is no electric current will generate. So the main idea of making the dynamo is the kinetic energy change into electric energy. You remember what is the kinetic energy? It's the energy that produced from the motion or the movement of the object. Here, when we move the magnet, inside the coil copper wire, the electric current generates. When we stop the moving of the magnet, the electric current stops generating. So the kinetic energy or the mechanical energy, kinetic meaning mechanical, kinetic energy or the mechanical energy change into electric energy. Okay, so we generate electric current by using a magnet, but the kinetic energy or mechanical energy here changing into what? Into electric energy. So the main idea of making the electric energy changing into magnetic energy. But in the dynamo, the very good kinetic energy or mechanical energy is changing into electric energy. So the dynamo here has another name, which is electric generator. So dynamo has another name, which is electric generator. Okay, and this is the shape of the dynamo, and the dynamo has two shapes. This is a shape, okay, and this is other shapes. Okay. Here in the electric generator or the dynamo, when you move a magnet inside and outside a coil of an electric current generated in the coil. This electric current is used to light the connected lamp. Here, here as you can see, that's the magnet and that's the coil of copper wire. Here by this thing we move this thing, so the magnet is moving. So there is an electric current generated and lights this lamp. Okay, so in the dynamo or the electric generator, the kinetic energy changing into electric energy. That's the shape of the dynamo, and the dynamo has another shape, which is this. The first shape we use a core magnet, but In the other shape, we use a, what is this? What is the shape of this magnet? Yes, U-shaped magnet or horseshoe magnet. Okay, okay. Here in this experiment, we have a U-shaped magnet and we have here a copper wire and we have here a device which called a meter. What is the meaning of a meter? A meter, it's a device that allow us to know the intensity of the electric current. Okay, what is the meaning of the intensity of the electric current? The amount of the electric current. If the amount is very big, okay, it will point it to a big number. If the amount of the electric current is small, it will point it to a small number. So here the ammeter, here, okay, it's like this and it contains here a pointer and here there's a numbers. Here. Okay, the pointer, okay, pointed to the number that equals the amount of the electric current. Okay, so the ammeter is a device that we use to know the intensity or the amount of the electric current. Okay, returning back to our dynamo. Here in the dynamo, this dynamo is consisted of U-shaped magnet and copper wire and ammeter. Okay, okay. Here at first, okay, we will not move, okay, the electric wire. The ammeter will move, the pointer of the ammeter will move, or is there any electric current will generate it? No. Why? Because in the electric generator or in the dynamo, the kinetic energy is changing into electric energy. When I am not moving the wire, so there is no kinetic energy, so there is no electric current will generate it. Okay? Okay. I will move the here, as you can see, I will move the copper wire between the two poles of the U-shaped magnet. So the electric current will generate it. Okay? Okay. Number three, I will move the copper wire between the two poles of the U-shaped magnet, but faster. I will increase the movement of the copper wire. What will happen? The intensity or the amount of the electric current will increase. So in this experiment, we do three things. Number one, we not moving the wire. What will happen? There is no electric current will generate. Number two, we will move the wire between the two poles of the electric current here. What will happen? An electric current will generate it. Number three, we will increase the movement of the wire between the two poles of the magnet. What will happen? The electric current will increase, or the intensity of the electric current will increase. So we have two shapes of the magnet. This is a shape, okay, and this is the other shape. This shape of the magnet, we called it small, this shape of the dynamo, we called it small dynamo. And this shape of the dynamo, we called it huge dynamo. So we have two types of dynamo, small dynamo and huge dynamo. Okay, so there's two types of dynamo, which are small dynamo and huge dynamo. The both of them are changing the kinetic energy into electric energy. Kinetic energy into what? Into electric energy. Okay? Okay. The small dynamo generates a small amount of electricity, but the huge dynamo generates a huge amount of the electricity. Let's start with the small dynamo. The small dynamo generates a small amount of electricity while we use it to do what? To light the lamp of the bike. Okay, do you have a bike on your home? Yes, this bike contain a lamp. If it contain a lamp. Okay, I'll ask you a question. Okay, can the lamp give you light when the bike is not moving? No. When you're moving the bicycle, the lamp will give you light, right? Right. Okay. What happened here? That is the dynamo that you can see inside the bicycle. And this is also here the dynamo. Okay? The dynamo here consists of this part. This part is a movable part. What is the meaning of that? When the tire, this is the tire of the bike. Okay? when the tire of the bike is moving, this part is also moving, okay? And this moving part is connected to a magnet. Can you see this part? Okay, that's a bar magnet. Okay, okay. And the yellow part here, it's the copper wire. It's the copper wire that coiled around the bar magnet. What happens when you ride your bike and start to moving the tire of the bike? Okay, this part will move, so the magnet inside the dynamo will move, and when the car magnet move inside or outside the coil of copper wire, what will happen? An electric current will generate it and pass through this wire that connected to the here that connected to the lamp, so the lamp will light. One more time. Here it's the small dynamo that generates a small amount of electricity. We use it to light the lamp of the bike. What happens when you move your bike? Okay, the tire is moving, so this part will move. So this part is connected to a power magnet, which will start to moving inside the coil of the copper wire that generate electricity that pass through this electric wire and reach to the lamp and make it light. Okay, okay, that's the small dynamo. Let's go to the huge dynamo. The huge dynamo generates a huge amount of electricity. It's used in the electric power station. You know what is the electric power station? It's the station that generates the electricity that we use in our home, and we use in everything that operated by electricity. Okay, okay. What is the uses of the huge dynamo? We use the huge dynamo to light the cities, okay, and operating the factories. Okay, okay. What is the shape of the huge dynamo? Here in the huge dynamo, we use the U-shaped magnet. Okay, that's the shape of the huge dynamo. It's very, very huge. Why? Because it generates a huge amount of electricity that we use in electric power stations and in lightening of the cities and to operating the factories. Okay, okay. So in the dynamo, we take the idea of making the dynamo, which is the changing of kinetic or mechanical energy into electric energy. And we know that the scientist Faraday discovered the dynamo. And we also know that there is two shapes of the dynamo, the small dynamo and the huge dynamo. Now we will know how to increase the amount of electricity that's coming from the dynamo. Number one, by using a strong magnet. Number two, by increasing the number of the coil turns of the electric wire. Okay, okay. We finished now Unit 1, Lesson 4 from Unit 1. Thank you for listening. Mr. Ahmed was with you.